In this ACT video, we're going to review trig identities. And trig identities are equivalent expressions that show relationships among the trig functions. The following list is some of the more commonly used identities, and it's definitely not intended to be an all-inclusive list, but these are the ones you'll probably see the most of. So we're going to start with some that we've kind of actually talked about before in the previous videos, and that's the reciprocal identities. So if we have y equals sine x, or if we just have the sine function, it's actually equal to 1 over cosecant x. And likewise, cosecant x is equal to 1 over sine x. All right, cosine x is equal to 1 over secant x, and secant x is equal to 1 over cosine x. And tangent x is equal to 1 over cotangent x. Likewise, cotangent x is equal to 1 over tangent x. And those are the reciprocal identities. The quotient identities are also referred to as the ratio identities, and those are just two of them. Tangent x is actually equal to sine x over cosine x, and cotangent x is equal to cosine x over sine x. Okay? It's important to note that we can take any of these trig functions and rewrite them in terms of sines and cosines. So notice the relationship between many of these that we've discussed and how they can be rewritten in terms of sine and cosine. That's something that we're going to hit up a lot in a couple of the examples. Pythagorean identities, we have three of those. We have sine squared theta, or sine squared x, that doesn't matter, plus cosine squared x is equal to 1. We also have secant squared x is equal to tangent squared x plus 1. And thirdly, we have cosecant squared x is equal to cotangent squared x plus 1. Now, it is important to note that we can do some manipulation of these and rewrite them. They mean the same thing, but they're written in a different form. So, for example, I might rewrite this one as sine squared x is equal to 1 minus cosine squared x, because I can just subtract cosine squared on both sides. I could also subtract sine squared on both sides, and that would give me cosine squared x is equal to 1 minus sine squared x. So you need to be familiar with the three Pythagorean identities as well as their alternative forms. Now, these are tied to Pythagorean theorem, so these only work with squares: sine squared, cosine squared, secant squared, tangent squared, etc. And last thing I'm going to talk about are two double angle identities. Sine 2x is equal to 2 times sine x cosine x. And that's a double angle identity because right here, 2x, that angle piece, 2 times anything is doubling it. And then cosine 2x is equal to cosine squared x minus sine squared x. And that can also be rewritten as cosine 2x is equal to 1 minus 2 sine squared x, or it can be rewritten as cosine 2x is equal to 2 cosine squared x minus 1. So this one also has some alternative forms. So you have to have these memorized so you know where to go with them. And let's take a look at some examples. We're going to use identities to simplify each of the following. So here we have tangent theta times cosine theta. And one of the key components is to start off by changing everything to sines and cosines. Okay, so if you get stumped on something like this, try changing things to sines and cosines. So what I mean by that is I can take tangent theta and use my quotient identity and rewrite that as sine theta over cosine theta. And then I can bring down the cosine theta. Then my cosine thetas cancel out and I've simplified this to just plain old sine theta. That's a really common one right there. But again, try changing things to sines and cosines. Let's try another. This is also a very common one. 1 minus sine squared theta over 1 minus sine theta. You cannot cancel anything out at this point in time. Okay? The sines do not cancel like this. But what you can do is you can actually factor this numerator because it's a difference of squares. So we can rewrite that as 1 plus sine theta times 1 minus sine theta. It's a difference of squares. All over 1 minus sine theta. And now the quantities cancel. So you couldn't cancel out just the pieces. You had to cancel out the entire quantity. We have a 1 minus sine theta in the numerator and a 1 minus sine theta in the denominator. So I'm left with just 1 plus sine theta. And that's completely simplified. Okay, and I think we have one more. Let's take a look at 1 over tangent theta times cotangent theta plus 1. Now, in this case, we may not want to rewrite this in terms of sines and cosines. Of course, you always could. But what I see here is 1 over tangent theta, this piece right here, is the same thing as cotangent. So what if I replace that with cotangent theta times cotangent theta plus 1, and cotangent times cotangent gives me cotangent squared theta plus 1. And using one of your Pythagorean identities, we know this is equivalent to cosecant squared theta. So there's lots of possibilities when using identities. It's important to know all of the identities I listed at the beginning of the video. And one of your main first steps in approaching something like this is to try converting things to sines and cosines. And if that doesn't work, move along the row and see if you see any of the other identities, like we just saw reciprocal identity here.